Welcome back. Now let us do the descriptive analysis. Descriptive analysis is defined like it's like you are trying to see the data from different dimensions. And why do we need to do this? When we are going to work with data, say 1 million, 2 million, sometimes even 1 billion, it's really not possible to understand the data through either from the simple statistics or seeing the head and tail. So you have to see the data in a multiple dimensions so that at least you understand the data a bit better. That is why you do the descriptive analysis. And I have written the few of the iterative functions all over. You see this one, numeric single. Numeric single means each numeric variable have been analyzed alone, and this function takes the train data and the response which we have already defined on the top, and all the images and every analysis it will save in a image folder which we have defined on the top. So let me run the folder image. It is named as images. So let us go and clean that first. So it has something and I'm cleaning. It is fully clean now. I'm running the line 211 and it takes hardly a minute or so, and then it is done. Once it is done, we are going to do the analysis one by one, and generally if you're working with a huge data, then it will take some time, so you have to run it in a batch, and once it is done, then you can do the analysis. Okay, and here we are having if you recollect, we are having total 8 features, and out of 8 features, 7 are numeric, so that is why it is taking some time. And once it is generated, you will see it really does some work. Okay, I think it must have generated few now. So yes, if you see that it has already generated one by one and is still doing it. So let us start with anyone, and let me make it a bit bigger so that at least yeah, I'm opening this in. You can open any one. All looks similar. I'm opening the accelerate one. So this has generated the 4 graphs. The first one is the histogram, and this is for the mean, that green color, and the red color which you see is the density graph. It means if this should have been the perfect normal, how the data should have been look like. But as I have explained earlier, in case of practical lab, you never get a perfect, but this is a good enough. How can you say? See, if you skewness, if you say the 0.29, it means on the right side the tail is little higher, little longer. Otherwise, it looks good. Okay, and thus this is the graph, the same graph without this red one, so that we can see the view properly. Good. And this is the box plot. Box plot is saying there are few outliers on the both directions. Otherwise, it is good. Looking good. And acceleration with response variable. So if you see the response variable, how they are related, somehow if you see that it is not the linear relation, because even though the linear curve has been tried to fit, there are good amount of points over here and here which is far beyond the straight line, and definitely it is not the linear. So this is the way analysis of each of the variables. So we have analyzed one. Similarly, you can open any one, and that is what you should be doing it. Open any one and try to do the analysis. Okay. So what I'm going to select all and delete all, because next one will be doing yes. Okay. Now this is the numeric double. Let me run it and then explain first. So I have run line 212. Numeric double meaning is that taking two numeric variables together and then trying to generate the graph. and so it will be done for by taking two numeric together. I think by this time it must have done at least once. Yes, it has done it. So okay, so somehow it is doing for MPG. I want without MPG. We want okay, let it complete. I want, see, this MPG means basically I know that MPG is already response variable. So doing with MPG and this one we have already seen in the previous one. So there will be partly the common image. I wanted to show you. Yes, if you see this one, say where it has gone. This, let it complete this one, then we'll see. Yes, cylinder and inter displacement. So see, cylinder and engine displacement both are two independent variable. So doing the analysis together, it is like this. First, you try to see whether there is any correlation in cylinder and engine displacement. But if you look like as the cylinders are going high, engine displacements are a bit bigger. It's getting in a straight line, which really makes sense. Basically, the more powerful your vehicle becomes, the more force it has. And when you try to see in a box plot, although it is somehow this box plot is not readable, and I will explain that in this situation what you should do, that if one of the box plots are not readable, how to immediately draw the box plot so that you can read the multiple plot in one go, because there's something is there. I will explain you at appropriate time. Okay, so this is the way to see that is there any outlier and so on. Now for each of these independent like engine displacement and cylinders, we try to see the outcome with dependent variable, that MPG. This is MPG, MP both. So what is the relation? It looks like okay, there is some curve fitting over here, but again still not the perfect, because there are a lot of the points which are away from the curve, and here also. It may happen that these fewer outliers, but this is little bit good. Somehow it is good, better than this one. So this is the way we analyze two numeric together. Okay, and I think it is still doing it. And next one is categorical single. It means each categorical it will take alone and try to do the analysis. And if you recollect, in our data we have only one categorical variable, so it will happen very fast. This is still doing it. Privanoli is still doing it, so I think we can stop it, because yes, it has stopped. So let me clean up the image. I have cleaned the image folder. Okay, so it will do the very fast. Line 2 and 3 will happen very fast because we have only one categorical variable. And similarly, there is a one function for two categorical. So if you are working at a huge number of categorical, please run that as well. So here the categorical variable has come. So it is the first one is showing the count of each of the level of the categorical variable. That American is having 245, Japanese 79, European 68, and so on. And this is with respect to on an average. American is MPG is giving around 20, European 27, Japanese 30. So if you see that this is the one observation over here, that Japanese mileage are very higher compared to American and European. Then come European. European is around 10% lower than Japanese, and American is 50% lower than the Japanese. This is one of the analysis that you should show to the business. Okay, so this is the, and the next one is let me run it because it takes time. So we are trying to see the all numeric at once. And so if you recollect, we had the 7 numerics. So you will try to do the analysis of all the 7 numeric at once. Okay, it has done it. It has done the few things. This is the skewness of each of this one. And I hope from the statistics you know what is the skewness, very variable. So it looks like ear is almost normal, and the horsepower is right skewed, and remainings you can interpret on your own. This is the skewness. Correlation. Let me show you this first correlation. Okay, what it is saying, if you see this, it is trying to find it out the correlation of all these variables among each other. So if you see, it looks like it has not given what is the meaning of this red and blue. Ideally we should print it over here that red means negative or blue means positive, but somehow it looks like it is missed out. So we'll do it later. Let me show you this is the value. Okay, if you see that highly correlated, this word weight and engine displacements are highly correlated. Weight, engine displacement along with weight, this is highly correlated. So blue means all the positive ones. Almost this is what you should read it. If now you should read that the more blue it has, positive correlation, red negative correlation, and white means almost near to the zero, but no correlation. That is what you should read it. So if you see this engine displacement is positive correlated with cylinders and weight. Horsepower is positively correlated with engine displacement, cylinders and weight. Accelerate is the negative with horsepower, partial negative with engine displacement, similarly in cylinders, and little more or little less negative with weight. And actual values are here. It will be correlation. I know that this you have learned in your statistics class. So this vary between -1 to 1, and -1 extremely not correlated, and extremely negative correlated, and power +1 positive. Okay, and sometimes it happened that he wanted to know only the +1, that is the highly positive one or highly correlated. So this is the file that is there for highly correlated. That's all. Highly means here I think I remember I taken the cutoff around 0.5. You can take the different cutoff as well. Okay, and there is one more for taking all the numeric, in one. Try to see the box plot of all. And if you see that we cannot see these box plots, I will explain you in future that how can we see the box plots of everything in one graph appropriately. Okay, so that's all for this one, and that's all. Thank you. Thanks for watching this, and I hope it was good learning for you.